Let's move on to our Slido poll. Let me see if I can get that one up here. That's that little Slido thing right in the bottom. Do I have to just press forward? Yeah, there we go. So we set up the Slido poll. Well, let's see how our audience is. This purpose of this is really just to kind of get a discussion, which oil and gas sector has the best. No. This is the wrong Slido poll. All right. Let's just move over and bring up the, that was the Slido poll for the next session. All right. We can fix that in the next session, but we can't fix it here. But maybe we should get a few comments on the show of hands of all of the energy resources. Let's move this one off. And we were kind of showing that coal was on decline, natural gas was going up. Who would seem to think that natural gas is likely to be our biggest source of power by 2030? I think a lot of us are thinking that. Obviously, solar and wind were both growing. I think wind was growing pretty fast at first, and solar has more recently made a lot of gains. Will solar and wind collectively were just rising at the same time coal was declining. So we have every expectation that the sum of solar and wind would be exceeding coal. Does that sound reasonable? By 2030. So coal will still decline. Obviously, there's a large amount of coal still being burned throughout our US, and a lot of that will be moving to natural gas perhaps. And in New England, we have moved most of our coal off of our grid, and our next problem, as Paul was showing, is how do we get natural gas? What's going to happen, and how do we replace natural gas? So let me think a couple of questions for our panelists. So Paul, you were showing us some of the distinct problems, and I know that you have consulted with the ISOs and the RTOs. Why couldn't, and you also demonstrated that there's all these state initiatives. We have the Regional Greenhouse Gas Initiative we have the Massachusetts S.95. We have all these state regulations that are telling utilities do this, utilities do that, and you're going to decarbonize this. Well, why didn't we just have FERC do all this? Shouldn't this be a federal function? Why is every state making their own rules and guidelines?
I think there's a relatively simple answer to that, and it's because the feds have not done it. I've often said there's a really, really simple way to do this, which is just put the right price on carbon across all sectors of the economy at the federal level and walk away. We don't need to be sponsoring winners and losers in the resource race. But obviously that's very politically challenging. So it's left to either the feds or the states to be looking at the data and deciding what looks like the most economic way to achieve decarbonization. Since it's not happening at the federal level, I think a lot of the states, the forward-looking states with respect to climate, have said we can't really wait, that the issue's too urgent and it's potentially too damaging to populations, and they've just gone ahead with their state regulations. And as I mentioned, I think the collective thought amongst the states that are taking action is that it's not happening at the federal level. If enough states do it, we can essentially create the economic and industry conditions for decarbonization without federal action. And it's true that the vast majority of the U.S. economy is actually, in terms of gross national product, is in the states that are active with climate laws. So, the impact of action by the states that have been very active is real. It actually amounts to, I think, even if you just look at the RGGI program, which is one small piece of what the states are doing, if you put together those states that make up RGGI, it would be the 5th largest country in the world. And so I think those states don't really feel the need for federal action. They don't need for FERC to do it or EPA to do it. They just feel that by collective action of enough states, you just create those economic and industry conditions for our economy to shift to a decarbonized economy.
Yeah, so if I'm part of these RGGI states and we're doing our fair share, what about those other guys that aren't? You know, of course, we love to blame China, you know, on all of the CO2 emissions they have. But at the same time, you see China is the massive developer of wind and solar.
Yeah, I think on the one hand, you can look at that and consider it a cause for inaction. But I think the states that have acted have gotten to the point where it's like, we can't not do something. They've come to the political conclusion that we understand the risks associated with climate change, and we need to reach net zero by 2050. And the fact that other states or countries are not doing it is just not a good enough reason to not start taking action on their own.
I can
All right, we have some questions from the audience. I see Peter back there.
I'll fit it in.
Hi, Peter Manos with ARC Advisory Group. TJ, my question's for you. We have in common that our original college degree was philosophy.
Okay.
I then went into engineering. Yours was economics. And my question for you is philosophical economical.
Okay.
I loved your mention of the 23 billion to 73 billion of external health costs, externalities, health costs associated with the reduction in natural gas fired generation that could be achieved with demand response. When I look at the annual EIA data on demand response and energy efficiency, it looks like it could be multiplied by 10 and still not be coming anywhere near saturating the market. It's much smaller than we would like it to be. Yeah. And my question is not about how those numbers are derived, but about externalities in a wider sense. How do we get the general public and decision makers and then policymakers to really touch and feel like the potential benefits that greater participation in virtual power plants with demand response could achieve? And I'm going to give you a very silly example. A couple weeks ago, my daughter moved out of the house for good. My wife said, "Hey, IKEA has a deal. If you return furniture fully assembled, we can get up to $250 for our daughter's desk." And I'm like, "Okay, honey." And I'm like, "Oh man, it won't even fit through the door. I have to disassemble it, bring it to IKEA, reassemble it." And when I ended up reassembling it, that particle board starts falling apart. I only got like $100 for the damn thing. I made less than $20 an hour for that effort.
Right.
Right? It's not like the engineer ROI, but you know what? I felt good at the end of that endeavor because I said to myself, that thing's not ending up in a landfill. Someone's going to buy it. So we get so into what's the ROI? Can we really get people incented financially to do this when they might be willing to pay a premium or go to some extra efforts that we haven't marketed very well, if that makes sense?
No, it's great. It's really important. I mean, I do think that you can also think about this, that there will be willingness, even in that circumstance. I think trying to ascribe some type of value to that is important, simply because there will be plenty of people who will say, "No way." I think that we can also kind of think about this more broadly. Some of the most fascinating work is around behavioral economics, right? And with O-Power, for example, we saw that just telling you what other people nearby you consumed is enough to get people to limit their consumption at any particular point in time. So I think that it is good to kind of think about sort of the broad incentives and not necessarily think about this solely around price. But I think that at the end of the day, especially to kind of justify this in the context of this versus new generating capacity, you do kind of need to have a sense of like, okay, what would the savings or the cost be for virtual power plants? So great question. And the final thing I'll say is on externalities. I'm going to talk about that a lot in the next panel. So yeah.
Questions up front here.
Yeah, this is more or less directed to TJ also. The thing I would want to bring up is how are you going to deal with the challenge of you've got this huge disparity of utilities across in states and municipalities and locals, all a complete range of different rules, regulations, et cetera. I know you brought that up as a challenge, but how are you really going to deal with that? Because I mean, I've had to contend with this personally. I mean, I have my own solar array. It goes back into the grid. one utility decides to spin off another one, they come in and they just arbitrarily change all the rules. One used to pay me for my power, now the other one decides not to. They don't seem to be constrained really by state, local, municipality, or local laws or regulations. They just seem to arbitrarily do what they want to do when they want to do it. So, I mean, that seems to be the reality that's really out there. So how are you dealing with that challenge? Because a lot of this power is going to have to be generated at almost at a residential level, if you will.
Yeah, I mean, this is probably there's probably a broader question around just, you know, how to incorporate DERs in general, not even sort of with a virtual power plant type business model. And I think the reality is that we've been kind of grappling with this since the order was put out in 2020. But I think that, you know, as we look forward, it is important to acknowledge that this can yield a lot of benefits and then find ways, you know, incrementally in certain circumstances where it might be really tough, but also try to accelerate and scale where we are seeing success. So not pretending that this is going to be easy, but also just highlighting that there is a huge opportunity here, and it can actually generate pretty widespread benefits. So yeah, take your point completely.
Do you have a question for Mike?
I have a question for Paul.
All right. It includes Mike? I got a question for Mike first, because I don't want to let him get out of this conversation, and then we'll come back to you, okay? So, Mike, today you demonstrated the fact that you have a 400-meter exclusion zone, that this is a walk-away safe reactor. The NRC that gave you that must have been convinced if they gave you such a small, exclusion zone, whatever. And so the two challenges for nuclear power to make a renaissance are cost and safety. It certainly seems like you guys have addressed the safety concern. What are you doing to get those reactors to be lower cost? Are you going to try to mass produce these in a factory? Are you going to try to project manage this so that the NRC never bothers you again and just lets you build them in quantity?
Yeah, so just to be clear, we have not completed the licensing process. We do have a safety case built, and we are engaged with the NRC to work through the licensing process. We're very confident that will work out as I described. With respect to the cost, there are several things that's not my area of expertise, but I will say that everything we're doing on the entire project is about design to cost. We're on a technical level, we're leveraging new technologies that are out there that will allow us to build multiple power plants, such as the boring technology that makes for instance, we're looking at the boring technology as being a way to save cost, and so we're building the plant to fit within that, specifically within that bore, with the idea that this is how we're going to build this thing. Because we're going to dig that hole in 3 years, in 4 years, this is where we're going to drop down in that hole. So really, with a sharp eye towards cost, and yes, modularization. I'm a big fan of the existing large reactors out there. They have struggled with cost. And one of the reasons is because it's been very difficult at that scale to achieve true modularization. Small modular reactors that are about a third of the size or less have a much greater opportunity to leverage building components and subcomponents and assemblies in factories, shipping them out to the site, bolting them together. So we are actively designing the plant to minimize things like the bespoke safety-related welding that has to take place on site. And yeah, everything we're doing is building the demonstration plant, but with an eye towards N+1, N+10, N+100 to really scale.
Yep, fantastic. We hope the utilities are hoping you're going to get there. Boy, they want that reactor. Next.
Well, now I have a question for Mike. Because you said about the cost, safety, but the third component is what are you going to do with the spent material? So it's still a problem, right? So that is not maybe less quantity?
That is correct. I mean, it's a physical reality that there will be output from the process. Now, one of the advantages of using the fast reactor spectrum is that it allows us to extract significantly more energy out of the raw material. So we would anticipate, you know, if an existing thermal water reactor extracts, let's say 10, 15% of the power from uranium, then sitting in that cask of spent fuel, there's still 80% of the power. By operating in the fast range, we would extract closer to 70, 80%, and then could even increase that through reprocessing, although that's a separate discussion I'm not ready to get into today. So we're not going to completely eliminate the spent fuel, but I can say that with the fast reactor technology that we and others are looking at now, we will have much less byproduct, and the byproduct that comes out will have much fewer harmful radionuclides. It actually gets burned up in the fuel process.
Okay, thank you. So my initial question was for Paul, and it's related to renewables. So we have gone through periods in our history where renewables were incentivized by the government, right? Solar and turbines, solar and wind turbines. But then you have the next administration deciding that it's not a priority anymore. Incentives are cut off. And so it makes the industry one that is not very attractive for investment or puts a lot of uncertainty in the investment. I somehow feel with this administration, big investment, but I still think we have this uncertainty of, will the next generation, next administration think differently, and then suddenly we have a much bigger problem than what you described.
Yeah, I have a couple of random answers to this. So in the past, there were supportive technologies for renewable, supportive incentives at the federal and the state level for renewable technologies, but the technologies themselves were very expensive. So it's not like those incentives, those government incentives caused those technologies to take off immediately. But I think there's very little doubt that the reason solar and wind have become so incredibly economic right now is because there were investment opportunities because of past government regulations supporting them. I think if you talk to the states that are absolutely gung-ho to achieve net zero, and the current administration, federal administration, there's a lot of money going into R&D, and there are a lot of very specific policies that force the development and construction of advanced technologies that currently right now don't necessarily look economic. Battery storage is an excellent example. Offshore wind went from, we were Cape Wind, when it was being proposed to the state of Massachusetts back in the day, was something like 22 or 23 cents a kilowatt hour. And now the proposals that are coming into the Northeast states for wind power in the same area are coming in at 7, 8, 9 cents a kilowatt hour. So I think that the state policies absolutely have played an incredibly important role in pushing the technology to the point where it's economic and it becomes economic on its own. And you can start to walk away from the subsidization. And that's certainly the mindset of the policymakers that are pushing these technologies. One of the reasons I mentioned this isn't your normal public policy challenge is because in the past, when we have done pollution abatement regulations, it's always with an eye towards what technologies are available, best available control technologies. Whereas now, what's so different about climate change is we're passing requirements now in state legislation where we have absolutely no idea what's going to help us achieve what the policies state very explicitly. So not only have renewables really become an extremely important part of that, I think the states are banking on the fact that these regulations and incentives are in place will cause the technologies that will be needed in the 10 to 30 year time frame to emerge, like the ones that both Mike and TJ were talking about.
So this question is probably a combination for Paul and Mike. So unless my understanding is inaccurate, the current influx of offshore wind provides us with a lot of power that's needed, but again, unless I'm mistaken, the current infrastructure does not support accepting and distributing that power. And I'm wondering if you gentlemen have any insight behind that and solutions to it. And the part of this that goes to Mike is, are we going to face the same thing with the advent, or call it rise, of these fast nuclear plants, and then at the same time, we're faced with the increase on mass scale of electrification that the utilities are trying to put forth?
I can take a first cut here. I mean, you're highlighting what is absolutely the number one technical infrastructure challenge for decarbonization in the states that are pushing it. Right now, and I'll speak to offshore wind, and Mike can speak to nuclear, where, nuclear, you can locate it where the infrastructure exists. Offshore wind, not so much. You have to land it somewhere on shore. All of the proposals that have been submitted and accepted by states for offshore wind projects in the Northeast include in their price the cost of the transmission, meaning the transmission to get it from the wind farm to a location on the grid in PJM or New York or New England, but also what the grid operator says you need to invest so that that power can be moved freely throughout the region. So the responsibility of the developer is to pay for the transmission infrastructure to do it. Now, what the states are grappling with is that only amounts to 5,000, 8,000 megawatts of offshore wind that's currently being developed, and it can land and it can be used within those power grids. But the states want 3-4 times that amount. And everyone recognizes there's no way that we don't need some sort of massive transmission infrastructure build out to accommodate it. That can't be built into the price of that additional 10 or 20 gigawatts of offshore wind. So the states New Jersey has sort of went through an excellent process with PJM. Other states are doing the same thing right now to say, we can't have a separate line coming in from every single project. We need to figure out how the states need to develop an integrated transmission infrastructure without it being, done on a project-by-project basis to support the integration of all this. So it's a big issue. And not just with offshore wind. All the proposals for decarbonization involve build out, access to wind in the Midwest requires massive amounts of transmission investment. So I think there's a ton in the IRA, there's a ton of support for developing those types of transmission resources, but it's still, who knows whether or not it'll be enough. It's still a big issue.
Mike?
Sure, and so from the perspective of the natrium nuclear reactor, a sort of simplistic answer is, these can be scaled to size, but we've intentionally designed this first iteration of natrium reactor to approximate a medium-sized coal plant. And in fact, the natrium plant that we'll be building first in Kemmerer, Wyoming, will be taking the place of a retiring coal plant. And that's sort of the short-term, I don't want to say business model, but to address the problem about being able to, the idea is that as coal plants retire, the coal plant goes away, a natrium plant goes right there, there's existing transmission infrastructure right there. We don't have to do a lot of new siting, the construction is easy, and we won't have to worry about, say, the concerns that the wind does currently that you bring up. Additionally, the energy storage will ease some of the transmission, it will allow some flexing back and forth between renewables on the grid in that location. I hope that answers your question.
Thank you.
All right, I think we have time for maybe one more question.
Real quick one for Mike. So Gen 4 reactors are walk-away safe, supposed to be. But I think one of your big hurdles that you have is public perception, which drives regulation, which also gets in the way and adds to the expense of making nuclear reactors. What are you guys doing to try to improve public perception for the new technologies that you have available?
That's a great question. It's a bit out of my lane, but I will say, we're actively participating in organizations like the NEI, Nuclear Energy Institute, where we're trying to get the word out through forums like this. Also, the Nuclear Regulatory Commission is not blind to this issue of climate change and the need to decarbonize the grid. And Nuclear Regulatory Commission is our partner. They're not our enemy, but they do fully, I believe that they recognize the perception and the truth that any regulation that is burdensome in nature and does not add value really needs to be cleaved away so that we can focus on the actual safety case. And they've come to the table, and they have passed new, as I was mentioning, our safety case will be built largely on probabilistic risk models rather than the old school deterministic models, which tended to lend to over-engineering and over-regulation. So I think there's some progress in the area of regulation that's helping that. As far as public perception, we just have to continue to operate without, with zero accidents and try to, it's an education exercise more than anything else, I guess.
A TikTok video, there you go.
You write that down.
I could add one point on this. So I teach a course, introductory energy course at Georgetown, and when I started about 5 years ago, all the students were super excited about solar and wind. So all the papers that they wrote were about solar and wind. In the last 2 years, I have had a surge in papers written about nuclear, SMRs in particular, and I think it just speaks to the fact that they are seeking sort of this next, what is the next big thing in a lot of cases, and they're willing to kind of, give nuclear a chance. And that's important, I think, in that for that generation as well, just knowing that, there's so much focus on climate. So I think it's a useful anecdote that I've kind of told many people, and they're in some cases surprised, actually. So.
Great. I'd like to thank our speakers for coming and for our audience.